When the world first heard about the SR-72, many dismissed it as another ambitious concept that would never take off. But as more details emerged, it became clear that Lockheed Martin was working on something truly groundbreaking, something designed to surpass the legendary SR-71. So, what's really happening behind the closed doors of Skunk Works? Has the future of American aviation already begun, quietly in secret? Join us as we explore the SR-72 upgrade, a next-gen, 5+ generation jet. Known as the Darkstar, Lockheed Martin's SR-72 is the long-awaited successor to the iconic SR-71 Blackbird, and it's finally stepping into the spotlight. Building on the SR-71's legacy, the SR-72 Darkstar is part of a top-secret U.S. Air Force project aimed at sky dominance and strategic power projection. But before we go deeper into the SR-72, let's revisit the aircraft it was built to replace, the SR-71 Blackbird. The SR-71 Blackbird is one of the most remarkable aircraft in aviation history. During its service, it broke speed records and set new standards in reconnaissance. Powered by two Pratt & Whitney J58 turbojet engines, it could hit Mach 3.2 and soar to 85,000 feet, so high that pilots needed spacesuits to stay conscious. For comparison, commercial jets cruise around 35,000 feet. The SR-71 flew so fast that it could evade surface-to-air missiles simply by accelerating. It was highly specialized, built to do what no other aircraft could. As a result, it shared virtually nothing in common with other planes, making it expensive and complex to build and maintain. For instance, it had the smallest radar cross-section Lockheed could design at the time, making it an early stealth aircraft. It was coated in black ferrite radar-absorbing paint that efficiently dissipated heat and gave it its signature look. About 85% of the structure was titanium, with the rest made from polymer composites. Engineers used a titanium alloy that was easier to machine but softened at lower temperatures. Due to the intense heat from hypersonic flight, the airframe panels were designed to fit loosely on the ground and align properly only when expanded mid-flight. However, this led to major fuel leakage before takeoff, much to the frustration of ground crews. Another unusual design feature: the SR-71 skin was corrugated rather than smooth. Aerodynamicists jokingly called it the Mach 3 Ford Trimiter, after another aircraft with similar skin. But this wasn't just for looks. Smooth skin would crack under high temperatures, while corrugation allowed it to expand safely in multiple directions. Stealth was a top priority. Engineers even added cesium-based fuel additives to make exhaust plumes less detectable by radar. In 1974, the SR-71 broke the record for the fastest London-New York flight. In 1976, it became the fastest manned air-breathing aircraft, a record it still holds as of 2025. Yet, despite its brilliance, the SR-71 was unsustainable. With operating costs of around $200,000 per hour, it was far too expensive to maintain. That was partly because only 32 units were built, making spare parts and logistics a nightmare. Its unique build meant it needed constant, specialized maintenance. The SR-71 also required a highly specialized logistics network, especially for exotic fuel, which alone cost $18,000 per hour back in 1989. That hefty expense became a major reason why Congress decided to retire the aircraft. The Blackbird was first retired in 1990, before the fall of the Soviet Union, but was briefly reactivated between 1995 and 1998 at Congress's insistence. It was officially retired by the Air Force in 1998, although NASA operated the last two airworthy jets until 1999, after which they were permanently grounded. As years passed without a direct replacement, pressure mounted to fill the gap. The Blackbird was unmatched. Reports claim the SR-71 outran over 4,000 missiles during its service. It flew with near impunity, even in hostile airspace. Replacing that level of capability was no small task. While many believe SR-72 rumors began in 2007, discussions actually started in the early 2000s. That's when Skunk Works recognized that the SR-71's era was over and began planning its successor. The years 2006 to 2007 were pivotal, Lockheed engineers teamed up with Aerojet Rocketdyne to develop a hypersonic-capable engine. They integrated scramjet, supersonic combustion ramjet, technology into what would eventually power the SR-72. The SR-72 wasn't just about speed. It introduced an entirely new class of aircraft. Designed to fly over 4,000 miles per hour, well beyond Mach 5, it promised performance unlike anything before. For context, it could cross the Atlantic in just over an hour. Unlike the manned SR-71, the SR-72 is fully unmanned and reusable, earning praise for its ability to fly through dangerous airspace without risking a pilot's life. This aircraft is so fast and autonomous, it can outrun even the most advanced surface-to-air missile systems. That's the direction the future of aviation is heading. But what is the SR-72's real mission? While it will surely shatter speed records, it's not built for show. The SR-72 is meant for high-speed reconnaissance, surveillance, and even deep strike attack missions. Its hypersonic speed allows it to enter and exit enemy territory so quickly, the enemy may never know it was there, until it's too late. In essence, it's too fast to catch and too smart to stop. It's also expected to serve as a launch platform for hypersonic weapons like the high-speed strike weapon, currently under development. So the SR-72 isn't just a spy in the sky. It's also a heavily armed attack drone, packed with next-gen capabilities. This aircraft marks a major leap in modern warfare. Compared to today's jets, the SR-72 shifts the strategy from slow and detectable to fast and invisible. Speed isn't just about moving faster. It's about gaining the upper hand, disrupting enemy response time, and shaping the battlefield. With the SR-72, U.S. commanders could gather intelligence or strike a target before the enemy has time to react. Although many once thought this aircraft was a myth, Lockheed Martin confirmed in 2013 that the son of Blackbird was in development and would fly twice as fast as the original, reaching up to Mach 6. They backed this bold claim by pointing out that the SR-71 was built using 20th century tools, slide rules and paper, without software or advanced computing. By contrast, the SR-72 is engineered with 21st century tech, a radically more advanced machine for a radically different era. Just 3 years after Lockheed Martin first confirmed the SR-72 project, CEO Marilyn Hewson revealed a major update. The company was on the brink of a technological breakthrough. This would not only allow the SR-72 to reach Mach 6, but also enable creation of a hypersonic prototype, about the size of an F-22 Raptor, for under $1 billion. In 2018, Lockheed Martin VP Jack Oben reaffirmed the 2013 announcement, stating that progress in additive manufacturing and advanced computer modeling had been key to bringing the SR-72, nicknamed the son of Blackbird, from concept to reality. The SR-72's primary weapons will almost certainly be hypersonic missiles, which are currently under active development by the U.S. military. Some experts argue that launching such missiles at extreme speeds creates intense heat and pressure, posing serious engineering challenges. But Lockheed has experience. They previously launched air-to-air missiles above Mach 2 using YF, 12 interceptor prototypes. Still, developing tech at this level is far from easy. To survive and perform at sustained hypersonic speeds, the SR-72 must endure extreme temperatures, rare air pressure conditions, and massive structural stress. At the core of its power lies a revolutionary engine, the turbine-based combined cycle, TBCC, propulsion system. No single engine works efficiently across subsonic to hypersonic ranges, so the SR-72 uses a hybrid, a standard jet engine for takeoff, and a scramjet for speeds beyond Mach 5. Here's how it works. The turbine engine lifts the aircraft off and powers it through the lower atmosphere. As it climbs and speeds up, the scramjet takes over for a hypersonic flight. This transition is incredibly complex and is a key reason hypersonic aircraft are still rare. As the SR-72 accelerates, incoming air grows so hot and fast that it would destroy a normal engine. So the turbine must shut down and be bypassed, letting the scramjet, which has no moving parts, compress air at high velocity for combustion. Keeping a flame stable in such fast airflow is like trying to light a match in a hurricane. But propulsion isn't the only obstacle. The aircraft must survive intense aerodynamic heating. Friction with the atmosphere generates enough heat to melt most materials. To solve this, engineers are using next-gen composites and heat-resistant alloys, many still experimental, to build an airframe that can endure heat, expansion, and contraction from repeated high-speed flights. The idea that the U.S. could send a hypersonic surveillance or strike aircraft anywhere in the world faster than a parcel is thrilling. But despite all this potential, the SR-72 project still faces a major barrier: funding. Although it aligns with the U.S. Air Force's hypersonic roadmap, full-scale development of both aircraft and engines still lacks financial backing. While the Air Force showed interest, it declined to fund the project, choosing instead to pursue the Northrop Grumman RQ-180, a stealth UAV expected to be cheaper and simpler for ISR missions in contested zones. Of course, skeptics weighed in too. In early 2018, Lockheed's Executive VP of Aeronautics, Orlando Carvalho, denied that the SR-72 had been built, stating that hypersonic R&D was focused on weapons. As the technology matured, he suggested it could enable a future reusable vehicle, stepping away from the SR-72 label and using broader terms instead. Still, by late 2018, Lockheed confirmed that an SR-72 prototype was scheduled to fly by 2025, equipped to launch hypersonic missiles. Testing for the single-engine SR-72 prototype was originally expected in 2025, but now, full operational readiness is targeted for 2030. Assuming all goes to plan. Still, nothing is guaranteed. Massive technical challenges remain. Flying at sustained hypersonic speeds generates heat intense enough to melt standard materials. To meet this demand, engineers are testing next-gen heat-resistant composites. But surviving short bursts isn't enough. The SR-72 must endure extreme conditions for long periods. In essence, it has to fly through fire. So why the urgency? The answer: global competition. China and Russia are already pushing hypersonic weapons and glide vehicles. If the U.S. doesn't keep pace, it risks falling behind, not just in tech, but in strategic edge. The SR-72 isn't just a fast plane. It's a clear statement of intent. It signals U.S. air dominance well into the future. It's saying, we're still here, still ready, and still faster. But the real power of the SR-72 isn't speed alone. It's the ability to shrink the reaction window. What used to take hours could now happen in minutes. It merges surveillance and strike into one swift motion, leaving adversaries scrambling before they even realize what happened. Of course, with that power comes risk. The SR-72 isn't just a military tool. It's a diplomatic wild card. Even without official confirmation, its rumored existence causes ripples in Moscow, Beijing, and beyond. Is it real? Is it already flying? The Pentagon remains silent, and maybe that's the point. Its shadow alone keeps rivals guessing. As 2025 nears, the world watches. Can Lockheed Martin and the U.S. turn one of aviation's boldest visions into reality and launch a new age of flight? It's also worth noting that while many call the SR-72 Darkstar, that name isn't official. A more accurate nickname is Son of Blackbird. Military aircraft often get official names only after acceptance by the Air Force, names chosen with a mix of tradition, purpose, and internal protocols. Interestingly, Darkstar was also the name of the fictional jet featured in Top Gun: Maverick 2022. While that plane was Hollywood fiction, Lockheed Martin did build a realistic mock-up for the film. It was 69.5 feet long with a 5.5-foot wingspan and included real prototype parts, like flight sticks and instruments. An F-18 performed takeoff and flight scenes, later replaced with VFX based on the mock-up. Despite the obstacles, Lockheed Martin Skunk Works continues to push ahead, motivated by the huge strategic advantage the SR-72 offers. With its potential to reach any point on the globe in under an hour, the aircraft could redefine how nations handle intelligence, defense, and rapid strikes. If the SR-72 takes flight as planned, it won't just be another jet. It will mark the beginning of a new era in military aviation.